Okay, so we're going to talk about some very simple surfaces in R3. We'll do some more complicated surfaces in R3 a little bit later in this chapter, but here at the beginning we're going to just talk about some very simple ones. So the first one we're going to talk about is a sphere. And so geometrically we know what a sphere looks like. What we want to talk about here is the algebraic equation for a sphere. So if you think about what a sphere is, it's the set of all points that are a fixed distance, that would be the radius, from some central point. So that's really about distance, and the distance, that's the fixed distance, would be the radius. So one way to think about this equation is just to think about distance formula. But instead of d equals here, I'm going to have r equals because that's the distance we're interested in. And then all of the points, x, y, z, that are a fixed distance from x naught, y naught, z naught. Right, so this is really just distance formula with r for my fixed distance, x naught, y naught, z naught for a fixed point, that would be the center, and then this would be all the points x, y, z that satisfy this equation. This isn't usually the way you would see this equation written in your textbook, and it's usually not the way I write it, but it's a way to remember it. It's just distance formula. So the way I usually write it, and the way you'll usually see that written, is if you go ahead and square both sides of this and maybe flip it around a little bit, then you'll see an equation like this. All right, so that would be the equation for a sphere with center at x naught, y naught, z naught. And radius r. Okay, so this is an equation that you need to know and be able to remember. If you remember an equation for a circle in R2, this should look very familiar. Equation for a circle in R2 would be x minus x naught the quantity squared plus y minus y naught the quantity squared equals r squared. So you just have this extra z term when we're talking about in R3. So make sure that you know this and be able to leverage it whenever needed, really throughout the rest of the semester. Okay, so we're going to look at a couple of different kinds of problems that you might do with an equation like this. One of them is that you might be given 2 points. I'm just going to use the same points that I used in the last video. So I had a point A, 2, 3, negative 1, and a point B. We had negative 2, negative 4, 4. And we want to find the equation of a sphere that has these 2 points as endpoints of a diameter. All right, so if I want to find the equation of the sphere that has those 2 points as the endpoints of a diameter, I need to think a little bit about how I'm going to take that information and connect it to this equation of a sphere. To write the equation of the sphere, I need to know the radius of the sphere and the center of the sphere. All right, so the information I'm given here is that these are at 2 endpoints of a diameter. I know that the radius is half of the diameter. So in the last video, we found the distance between these 2 points was square root of 90, was the distance between A and B. And so our radius would be half of that. Radius is half of a diameter. So r is going to be the square root of 90 all over 2. Or you can write that in a simplified form if you like. The other important thing I need to know is the center of the circle, or of the sphere. So if you think about the radius being the distance from the center to the edge, and I know that these 2 points are at endpoints of the diameter there, then we can think about that midpoint between those 2 points would be at the center of the circle. So in the last video, we talked about midpoint formula and found the midpoint of these 2 points. We got 0, negative 1/2, and 3/2 for the midpoint of those 2 points. So I can use those 2 pieces of information, plug into my formula here for the equation of a sphere, and write the equation of the sphere that has these 2 points at endpoints of a diameter. So I'll go ahead and write that down here. All right, so our equation would be x minus 0, of course you can simplify that a little bit, the quantity squared, plus y minus negative 1/2, so plus 1/2, the quantity squared, plus z minus 3/2, the quantity squared, equals the radius squared. So I need to square this whole thing here. So when I square this whole thing, I'll get 90 over 4, or I can reduce that and write that as 45 over 2, or 22.5, if you prefer. All right, so there is the equation of the sphere. You can tidy that up a little bit if you want. It's not completely necessary, but if you like to do some algebra, you can do that. You could rewrite this part as just x squared. And then if you wanted to FOIL these parts out, you can do that as well. All right, another kind of problem that you might see in the homework is when you're given an equation of a sphere, perhaps not in this standard form for the equation of a sphere, and you're asked to find some information about the sphere. So let's look at a problem like that. So if we're given an equation of a sphere, say x squared plus y squared plus z squared minus 4x plus 6y equals 1, and we're given that as an equation of a sphere, and we're asked to find the center and the radius. So what I need to do is take this equation and do some algebra to manipulate it so that I get it into this standard form for the equation of a sphere. This is some algebra that it might have been a long time since you did, although you may have seen this in Calculus 2 when you did some techniques of integration. But we're going to use completing the square to rewrite this in this form. So I'm going to rearrange the terms here. So I've got the x terms next to each other and the y terms next to each other. And then what I'm going to do is add a number for the x terms, also add a number for the y terms to force this part into a factor where I can rewrite it in this form, x minus x naught, the quantity squared. So you might remember an algorithm for doing that. If not, here's your little refresher. You want to take half of this coefficient and square it. So half of negative 4 is negative 2. And then I square it, I get 4. So I'm going to add 4 for this part to make some factorization there. I have to add 4 to the other side of the equation as well. I'm going to do the same thing for the y's. I'm going to take half of this y coefficient, so half of 6 is 3, and then square it. So that's a 9. So I'm going to add a 9 also to both sides of the equation. What that does is that forces the equation to factor. So we end up with x squared minus 4x plus 4 can factor into x minus 2, the quantity squared. And then the y terms will also factor. Y squared plus 6y plus 9 will factor into y plus 3, the quantity squared. The z terms here I don't need to do anything with. I can think about that as z minus 0, and it's similar to how we had this over here, equals. And then on the right side of the equation, if I simplify that, I get 14. All right, so here's the same equation of the sphere in one form and now in another form. It's just rewritten in two different forms. But in this second form, we can easily see where the center is. Just matching that up with our standard form from this formula over here, we see that the center is at 2, negative 3, and 0. Remember the minus sign is part of the formula here, so be careful about that. And the radius would be the square root of this. Remember that this side of the equation would be the r squared, so the radius is square root of 14. All right, so you should try some homework about the spheres in this section. We'll look at some planes in the next video.